Hello everyone, welcome back to Mathematics Schoolio. I'm Hansa and in this video, I have a very special question that intertwines concepts of coordinate geometry, differential calculus and integral calculus. So let's see what's the question. Here is the question. The question goes like this. Consider the parabola y is equals to x squared. Let a circle centered at 0, a be tangent to the parabola at b, c such that a plus c is 2b minus 1 multiplied by 2b plus 1. Now, if a is greater than 0, then find the area of the finite region between the parabola and the circle. So let's start. So question says that y is equals to x squared is the parabola, which I have already traced here for you. Let a circle centered at 0, a. So this is the red circle that they are talking about. It is centered at 0, a. And secondly, it touches parabola at b, c. It can also be there in the second quadrant. Symmetry says that the point b, c and the other point, if I write the other point as q, this is going to have some x coordinate which will be minus b, c. So I'm just assuming that b is positive without loss of generality. Fine. So circle touches the parabola at b, c such that now the first condition that they have provided or the relation that they have provided between a, b and c is a plus c is 2b minus 1 multiplied by 2b plus 1, which I can write as a plus c is equals to 4b square minus 1. I'm just writing it inside a box and writing this one as the first relation. Now a is greater than 0. That's why I have made a circle with center on the positive y-axis. Find the area of the finite region between the parabola and the circle. So which area do we have to actually calculate? See, I'm just shading this with yellow. This is the region whose area is to be calculated. And again, the symmetry says that just calculate the area in the first quadrant and make it twice and we will get the answer. So I will just be concentrating on getting the area of the first quadrant. Well, let us see what exactly do we have to do in the question. So let me just brief you the outline what I'm going to do for the solution part. What I'm going to do is I'll concentrate purely on the coordinates of P. That means I'll try to get the coordinates of point P, B, C. Once I get the coordinates of P, B, C, my next step would be just joining AP. Join AP. Drop the perpendicular from P on x-axis. And then you can see that you will have a trapezium over here. So we have a trapezium over here, which can be written as O. I'm writing this point as B. So OBPA. So once I get the coordinates of P, my next step will be either going in the direction of integration and getting the answer, or without the help of integration, I'll take the help of this trapezium and will be subtracting some unwanted areas to get the required area. Well, in both the cases, I need the coordinates of P. So the outline is getting the coordinates of P and then proceeding with the integration or without integration. So let's start with, first of all, getting the coordinates of P. How we are going to get the coordinates of P now? To get the coordinates of P, let us see what all relation they have provided here. They have given that the circle touches the parabola at the point B, C. So first thing that is coming to my mind is B, C must satisfy the equation of parabola. Y is equals to x squared is the parabola. Point B, C is on the parabola. So I will write it as C is equals to B squared. This is one more relation that we are getting between B and C. I'm marking it as 2. What next? The point is on the parabola and the circle touches the parabola. So whenever two curves touches each other, we have a very special property which says that at the common point of contact, which here you can see as P, at the common point of contact, we have dy by dx similar for the two curves. So we will say that dy by dx is same for the circle as well as for the parabola. Or you can also write it like this, that the two curves which are touching each other will have a common tangent. At the common point of contact. That is, at the point P will have a common tangent between the circle and the parabola. Now, how to use this concept? We are going to use this concept as, first of all, for the parabola, I'll make use of dy by dx because I have the equation given in the problem. Okay, so let's find out dy by dx at the point P, which turns out to be, for the parabola, the derivative is 2x. At the point P, when you calculate, it turns out to be 2b. So I'm just going to equate the slope of the tangents at the point P for the two curves. For the parabola, I calculated slope of the tangent using calculus approach. Now I want to find out the slope of the tangent drawn to the circle at the same point, but now I'll make use of coordinate geometry. Obviously, because I don't have the equation of circle, I cannot go for dy by dx here. But can we go for coordinate geometry? Yes, we can easily go for coordinate geometry because you can see that P is the point of contact at which I need to draw, or at which I need to get the equation of tangent. And I have joined P with the center of the circle A. So AP is nothing but normal to the circle at the point P. And that is the reason slope of the tangent to the circle at the point P will have the value equals to negative reciprocal of slope of the normal at the point P. Or I can say slope of the line AP. So I'm going to calculate it using coordinate geometry and will write it as -1 upon C minus A upon B minus 0. Let's continue with the calculation part. What we are getting? We are actually getting this relation. B can be cancelled because I'm not taking 0. I'll consider B equals to 0 and will solve it separately. So let us make the cases here itself. What happens if we have B 0? And what happens if we have B not equals to 0? So I'll take the case B 0 and B not equals to 0. So numerator may, when you take B equals to 0. Now see, when B is 0, from the second equation I can say C will also be 0. But if C is 0 and B is 0, then from the first equation, just go and put B and C equals to 0. If I put B0 and C0 in the first equation, what I'm getting is the value of A, which turns out to be -1. And in the question, it is very much clear that A is greater than 0. I can't take A negative. So since I cannot take A negative, that is the reason B cannot be 0 as well. So I rejected this case because I was getting the value of A as -1. So I rejected this whole case. Now I'm proceeding with taking B not equals to 0. So when B is not equals to 0, I'm actually getting from these two, 2 times C minus A is equals to -1. Or we can say that C turns out to be A minus 1 by 2. I got one more relation between A and C. This is the third relation. Now I just have to make use of 1, 2, and 3 to get the values of A, B, and C. I'm going to put all these values. That means replacing C with A minus 1 by 2 in the first equation, replacing B square with C in the given equation, and then I'm going to proceed. So the equation will turn out to be A plus C on the left hand side. So C ko you can replace with A minus 1 by 2. On the right hand side, what do we have? We have 4B square minus 1. So B square I'm going to replace with C, but C ko I can replace with A minus 1 by 2 and -1. When you solve this equation, the value of A turns out to be 5 by 4. It's a simple linear equation. When you solve it, you'll get the value of A as 5 by 4. But since I get the value of A, I can calculate the value of C as well. C is A minus 1 by 2, which turns out to be 3 by 4. And that is the reason now B also we have, which turns out to be √3 by 2. I told you earlier in this question that I'm taking B as positive. So B is plus √3 by 2. Fine. Now I have A, I have B, I have C, all the three values. Because A, B, C all are there. Basically, I was doing all these calculation part to get the coordinates of P. What are the coordinates of P that we are getting? B, C. B, C means √3 by 2, 3 by 4. These are the coordinates of the point P. Fine. Now I have the coordinates of point P. What next? So what next, Kelly? I told you that we can proceed in either of the two ways. Either we can make use of integration, or without integration also we can solve this question. So first I'm preferring without integration method. That is going to be a little bit more easier. So let's proceed. I'm just going back to the parabola. I'll show you the parabola. Then we will see what we have to do. Without integration, actually what you have to do. Now, because you have the coordinates of B, C, √3 by 4, 3 by 4. Now, first of all, I will be calculating the area of trapezium OBPA. So let us calculate the area of the trapezium OBPA. And from that, two things I'll have to subtract. One thing that I need to subtract is the area bounded by the parabola and x-axis in the first quadrant between 0 to B. And second thing that I need to subtract will be the area of this sector of the circle. Can we get the area of this sector of the circle? To get the area of the sector of the circle, you need to find out this angle. You need to find out the angle. How to get that angle? I'm just dropping the perpendicular from the point P on y-axis. Since I know the coordinates of the point P, we can easily write that OP distance, not exactly OP, let me write this one as P dash. So P dash distance is equals to root 3 by 2. What about AP distance? Yes, it can be calculated because A is 5 by 4. Keeping the value of A here and calculating the distance AP, it turns out to be 1. So using distance formula, you can easily calculate the distance AP. AP is nothing but the radius of the circle. So I actually got the radius of the circle as 1. And in the right angle triangle APP dash, perpendicular is root 3 by 2. Hypotenuse is 1. That is the reason we can say that from the triangle, we have sine theta is equals to root 3 by 2, which ultimately gives me the angle theta as pi by 3. So I have the angle to get the area of the sector. Now, since I have all the three values means, first of all, area of the trapezium, OBPA, yes, we have it. Secondly, can we calculate the area of the sector? Yes, we can. Can we get the area under the parabola? Yes, but for this, I need integration. So I'm going for the integration part. So I will be writing down now method 1. What is method 1? First of all, calculating the area of the trapezium. So it is going to be OB, P, and the center of the circle that we have taken is C, A. So OBPA minus area of the sector and minus area under the parabola. Area under the parabola in the first quadrant from 0 to B. From 0 to B. So all these three values now we are going to calculate individually. First of all, OBPA. So OBPA says that half sum of parallel sides multiplied by height. So when you calculate or put all these values, the sum of parallel sides, which is going to be A plus C. So we know that A plus C, it is 5 by 4 plus 3 by 4. And the distance between parallel side turns out to be B, which is root 3 by 2. So ultimately, the area of OBPA turns out to be 1 by 2 multiplied by 2 multiplied by root 3 by 2. Now coming to the area of the sector. So area of the sector ke liye what all things are required? 1 by 2 r square theta. So do we have r, the radius of the circle? Yes, we have seen that it turns out to be 1. What about theta? Yes, that also we calculated. It turns out to be pi by 3. Now what? Now I need to subtract the area under the parabola from 0 to b. So what is that area? It will be 0 to b x square dx. So let us complete the calculation part. It is root 3 by 2 minus pi by 6 minus. Now it is x cube by 3. So b cube by 3. But what is b cube? So you can see that b cube is root 3 by 2 ka whole cube, which is nothing but 3 root 3 upon 8. It turns out to be 3 root 3 by 4, 3 root 3 by 8. Now we have minus pi by 6. But remember, the area that I have calculated right now is only the area of the first quadrant. Since I have to find out the complete area between the circle and the parabola, I need to make it twice as I explained you earlier. So that's why now the total area bounded between the parabola and the circle turns out to be twice of 3 root 3 by 8 minus pi by 6, which ultimately gives me the answer as 3 root 3 by 4 minus pi by 3. So here is the answer that we have, and here I have not used a lot of integration. Yes, for calculating the area under the parabola, I have used integration over here, but other than that, we have avoided integration and solved the question. Well, method 1 is also a very good method to get the answer. Let's see what is the other method to get the similar answer or the same answer. So as I told you, method 2 I will be using the integration. Now I'll be using pure integration here. What do you mean by pure integration? Actually, I have the center of the circle and we also have the radius of the circle now. So first of all, I'm just going to write down the equation of the circle here. Let's see what exactly the question says. So here is the circle. And what about the parabola? We have the parabola y is equals to x square. What we need to find out is the area between the circle and the parabola, between the point of contact of these two curves. And we have calculated its point of contact in the first quadrant, which is b comma c, root 3 by 2 comma 3 by 4. Okay, so let us go back to the parabola and let's see how we are going to calculate this area using integration. So between 0 to b, just as on the method 1, here also I'm going to calculate the area in the first quadrant and will make it twice. But here now what I'm going to do is I will be integrating the upper boundary. As you can see, the upper boundary I'm going to take as the circle ka boundary minus the lower boundary, which is the boundary of the parabola, between 0 to b. So we are going to calculate the area of the first quadrant by integrating between 0 to b, the upper boundary minus the lower boundary of the bounded region. So upper boundary we will have to take the circle and lower boundary it is going to be parabola. So chalo, let's write it and calculate the area. So calculating the area, writing it properly. Now I'll say that my answer is going to be required area will be twice of integral 0 to b. Yes, I have the value of b. That's why I'm putting it over here. Upper boundary. Upper boundary means you will get it from here. And circle has two branches. So you have to take the lower branch of the circle. And that's why I'm going to write it as 5 by 4. See, the center of the circle is 5 by 4. So we have center of the circle 5 by 0, 5 by 4. It will become 5 by 4 minus root over 1 minus x square minus the lower boundary, which is actually a parabola, x square dx. All the three are like the standard or easier integrals which can be evaluated. But still, I'm just showing you the calculation part over here. 5 by 4, when you integrate, it will become 5x by 4. Coming to minus x square ka integral, it is x cubed by 3. I'm going to put the limits over here, 0 to root 3 by 2. And we'll solve the integral 0 to root 3 by 2, root over 1 minus x square dx by using the trigonometric substitution. Moving ahead, completing the calculation part. The first term will become 5 root 3 by 8 minus root 3 by 8. Numerator becomes 3 root 3 upon 3 into 8. So 3 got cancelled. Lower limit pe everything is 0. But coming to the second integral, so the substitution that I'm going to use here is x is equals to sine of theta, which makes the lower limit 0 and the upper limit has changed to pi by 3. Root over 1 minus sine square theta means mod cos theta, which in the first quadrant between the limits 0 to pi by 3 will be positive only. In sine theta, x is sine theta, then dx is going to be cos theta d theta. Fine. So just 2 more steps and we will get the answer. Right now we have 4 root 3 by 8. So I'm writing it as root 3 by 2 minus. Multiplying and dividing it by 2 so that it becomes integrable. Writing once more 0 to pi by 3. 2 cos square theta means 1 plus cos 2 theta. Integrating term by term. This is 2 times root 3 by 2 we already have, minus 1 by 2 theta, and cos ka integral is going to become plus sine 2 theta divided by 2. The limits are from 0 to pi by 3. Now I'll put the limits Putting the limits gives me first term is still the same, but now it has become pi by 3 plus sine 2 pi by 3. So it is root 3 by 2 upon 2, and minus 0 pe everything is going to cancel. What next? Just completion of the calculation part. So we have 2 times root 3 by 2, and these two together gives me root 3 by 8. So it actually becomes 3 root 3 by 8 minus pi by 6. Multiplying it with 2 gives me the answer 3 root 3 by 4 minus pi by 3. So this is the second method which involves the complete integration process for getting the answer. Well, I would say that prefer the first one because it reduces the calculation part, but even if you proceed with method 2, you can reach up to the result. So I hope you must have enjoyed this problem. Thank you for watching. Bye-bye for now. Don't forget to subscribe the channel and like the video. Thank you all of you.